Okay, so we were talking about friction in class the last time I saw you, but we didn't quite finish. Okay, we did get to the equation friction is equal to mu Fn, where F with a subscript F is the force of friction. Fn is the normal force. And mu is the coefficient, it's called the coefficient of friction. Okay, we had also had it written down earlier as F over friction over the normal force is equal to mu. And if you look at it this way, you can see that mu's not going to have any units, right? Because it's going to be newtons over newtons. So the coefficient of friction does not have any units. It's the one you can leave units off without me taking points off. Coefficient of friction has a range of values, usually between 0 and 1, where 0 will be the smoothest surface and 1 the roughest. There's only one place really in your textbook, or in one place really that I've seen a mu over 1, and that's in your textbook. And we'll look at that chart in a few minutes. It's on page 140. Okay, the smoother the surface, the smaller the mu. That should make sense when you look at the equation, right? Because if mu is tiny, then mu times the normal force will be small. The bigger mu gets, then the bigger friction gets, okay? So mu then tells us about the surface, okay? And mu is constant for a given surface, but changes between one surface and another. And what I mean by that is like the coefficient of friction of my floor when it's dry and clean is probably about 0.3, 0.4. And so it will be today, it will be tomorrow, it will be the next day. Until I do something to change the surface, like put water on it or lather like Vaseline or something on it, then that changes the mu. But for a given surface, the mu is constant. So the mu for ice at Willie O'Reed when it's been Zambonied will be really tiny, but then as soon as you start cutting up the ice, the mu gets bigger. So for a given surface in a given amount of conditions, a given set of conditions, mu will be the same. That's why you often see those yellow caution signs. We have them here at school. They also have them, at McDonald's, at the mall. And on the outside it says, caution, wet floor. Really what that means is caution, the coefficient of friction of this surface has been changed due to the addition of water. The friction, therefore, is less, so walk carefully. Actually, if you're in some places, like at the mall, on the underneath side, it says, caution, the coefficient of friction has been changed. On the outside, they've gone with like the person falling on the wet floor because there's so many unphysics people among us, they wouldn't understand the other side. Okay, so this is our force of friction. We can use it as long as we know the normal force and as long as we know the coefficient. And there's a chart of coefficient of frictions on page 140 in your textbook. Okay, so it lists a whole bunch of different surfaces, and it has two columns for the coefficients. One column is the coefficient of static friction, and the other column is the coefficient of kinetic friction. I already mentioned in class that there are two different types of friction. Static is between objects at rest with respect to each other, and kinetic is objects that are moving with respect to each other, and that's where we're going in a second. But I just wanted to show them to you, and there's the one that's bigger than 1. Coefficient of static friction, rubber on a dry, solid surface. This would be like your tires on the road. Okay, dry concrete, wet concrete. The other thing you should notice before I move off this chart is that the static coefficient is always larger than the kinetic one, and we're going to talk about that in a minute. Okay, but if you need some from the textbook, you can look in that chart to get the mu's. All right, so there are different types of friction. The first type we should talk about is static. Okay, static friction is the friction between objects at rest with respect to each other. Okay, So the friction between objects at rest with respect to each other, if you're writing this down. And I can post this sheet of notes about them in the handout page if you want. So static friction is the frictional force that exists between objects at rest with respect to each other. Now what I mean by that is you might have a box of your grandmother's fine china on the back of the truck. And you might say to your friend who's driving the truck, okay, be careful, drive careful, because I don't want this box to move for the whole way while you're driving. And your friend's like, I thought we were taking it across the river. The box has to move. But what you mean is you don't want the box sliding about on the back of the truck. You want the box of fine china to stay at rest with respect to the truck. Okay, so static friction is the friction between objects at rest with respect to each other. It's also the friction that you must overcome in order to start the object from moving. It's the friction that you must overcome in order to start the object moving. Really, it's the friction that prevents the object from moving when you push on it. So here's your box, here you are, you're pushing on the box, and you're pushing with like all your might, but the box isn't moving. And that's because static friction then would be acting in the opposite direction. And it's bigger than what the force you're pushing with, so it won't move. Okay? So it's the frictional force that must be overcome in order to start the box moving, and it's what prevents a box from moving when you're trying. Imagine like an inclined plane, a ramp, and you have a box sitting on it. Well, if the ramp's steep enough or slippery enough, the box will slide down. But assuming that there's enough static friction on the ramp, it will sit there. The box will want to go this way. There'll be the force of gravity acting down the incline, but static friction will be acting up. And so as long as the ramp isn't too steep, then the box will be able to stay there. Okay, now another important point about static friction is that it varies up to a maximum value. Okay, it varies up to a maximum value. Varies up to a maximum value. Okay, and once you hit that maximum value, then the object will begin to move. So once you push with a force bigger than the maximum static friction for a surface, the object will begin to move, and you've now moved in to kinetic friction. Okay, this is the friction that exists between objects that are moving with respect to each other. So these ones, objects that are at rest. These ones, kinetic friction, objects that are moving with respect to each other. So you're pushing this box across the floor. So with respect to the floor, the box is moving. So kinetic friction would be, of course, always opposing the motion. It would be acting back this way. Okay? Kinetic friction on a given surface is always less than static friction. Just going back to static friction for a second, to understand it, if you have an object that's sitting on a surface and it's sitting there for a bit, there's like temporary bonds that are built up between the bottom of this object and the floor or whatever it's sitting on. Okay, so these temporary bonds are being built up, and now you want to move it, you actually have to push with a force big enough to break these bonds. It's kind of like having one of you in the class with everybody else, and then someone comes and says, okay, you need to switch classrooms. Well, you've formed bonds with the people in the class, so you and them are all like, no, no, don't go. And you're hugging each other before you leave, and it takes some force to get you out of there. Now think about kinetic friction. Kinetic friction, the object's moving. So because the object's moving, it doesn't have time to form the same type of bonds as it did in static friction. In kinetic friction, it's like you can just give them all high fives as you're being removed from the room because you're already moving. Whereas up here, You formed those bonds because you